So I know a question that confuses a lot of people is how to figure out an object's position given the acceleration of the object. So it's pretty easy to derive. I'll show you how to do it. So let's start out by assuming we have a particle, and it's just for simplicity's sake, it's just moving in the x direction. So we'll say it has an acceleration of x that is known. So that acceleration in terms of x, we know is equal to its change in velocity in the x direction in terms of time. Now this is the tricky part that a lot of people get confused with, so I'll show you how it works. It's pretty simple. But we can break up this portion of the equation, the right hand side of the equation, into this. So dv of x dx multiplied by dx dt. And we're allowed to do this because of what's called the chain rule. And if you don't know what that is, you should look it up and you'll probably understand, or I'll explain in a later video. But so now we can see that these dx's would cancel. So we essentially have the exact same thing on the right hand side. Well, what we can do now is get its position. So dx dt is just another way of saying velocity. So we can write this as dv sub x dx times the object's velocity in the x direction. Now what we can do is separate variables, so we can put ax dx on the left hand side is equal to v sub x dv sub x. Now if we integrate both sides of this equation, like so, and we'll integrate this side from v initial to v final, and the left hand side will start at x initial to x final. So since the acceleration of x doesn't have any x's in it, we can pull it out in front and just say a sub x multiplied by the change in x. So x final minus x initial is going to be equal to vx final minus vx initial, and these are both going to be squared, and then both of them will be divided by 2. So you've probably seen this equation before somewhere in physics or dynamics. So Vx final squared minus Vx initial squared, we can put that all over 2. Since they're both divided by 2, equals a sub x, x final minus x initial. If we multiply the 2 to the other side, we'll get 2a sub x, x final minus x initial equals v sub x final squared minus v sub x initial squared. So if we move the vx initial over to the other side, we'll get a fairly commonly known equation. Vx final squared is going to be equal to Vx initial squared plus 2 times the acceleration in the x direction times the change in position in the x direction. So this is an equation you can use for a lot of different applications, such as things like if you want to find out how long it takes a car to stop, given that you have some initial velocity and it decelerates in a certain way, or I mean, there's other, random particle equations that you can use. But hopefully that made sense. If you have any questions, please let me know, and appreciate your time.